Good day, everyone. I'm John Junipino, and I'm going to discuss about problem-solving strategy number 6, looking for a pattern. Learning objectives. At the end of the lesson, students should be able to know the definition of looking for a pattern, the relationship of Polya's problem in looking for a pattern solving strategy, and the difference of looking for a pattern strategy from other problem-solving strategy, and worded problems applying looking for a pattern. Look for a pattern. Looking for a pattern is another strategy that you can use to solve problems. The goal is to look for items or numbers that are repeated or a series of events that repeat. The following problem can be solved by finding a pattern. This topic has a 4-step technique. And first is to identify what is the question asked. And second is plan. What strategy will use to solve the problem? And third is to solve. Carry out your plan. And fourth is to verify. Does my answer make sense? In 1921, he proved his famous theorem in a random walks on an integer lattice. Father of George Polya is Jacob Polya, and his mother is Anna Dutch. Nearly 100 years ago, a man named George Polya designed a 4-step method to solve all kinds of problems. Understand the problem, make a plan, execute the plan, and look back and reflect. Because the method is simple and generalized well, it has become a classic method for solving problems. In 1945, George Polya wrote how to solve it, and Polya created this famous 4-step process from solving problem which is used all over the aid of people in problem solving. First, step 1 is to understand the problem. Step 2 is to devise or translate. Step 3, carry out the plan or solve. And step 4 is look back, check and interpret. Step 1, understand the problem. In order to show an understanding of the problem, of course, you need to read the problem carefully. Once the problem is read, you need to list all the components and data that are involved. This is where you will be assigning a variable. Step 2, devise a plan or translate. When you devise a plan or translate, you come up with a way to solve the problem. Setting up an equation, drawing a diagram, and making a chart are all ways that you can go about solving your problem. In this tutorial, we will be setting up equation for each problem. Step 3, carry out the plan or solve. The next step, carry out the plan or solve, is a big. This is where you solve the equation you came up with your device plan step. The equation in this tutorial will be linear equations. Step 4, look back or check and interpret. You may be familiar with an expression, don't look back. In the problem solving, it is good to look back, check and interpret. Basically, check to see if you use all the information and that's the answer makes sense. If your answer does check out, make sure that you write a final answer with correct labeling. Relationship of Polya's method looking for a pattern. In this section, we will be applying the problem-solving plan you learned about in the last section to solve the several real-world problems. You will be learned how to develop a table and look for a pattern. And the method make a table is useful when you're solving problems involving numerical relationship. When data is organized in the table, it's easier to recognize the pattern and relationship between numbers. Let's apply this strategy to the following example. Andrew cashes a 180 check and he wants the money in 20 bills and 10 bills. The bank teller gives him 12 bills. How many of each kind of bill does he receive? First is solution. Method 1, making a table. And first is to understand. Andrew the bank teller a 180 check. And the bank teller gives Andrew 12 bills. And these bills are mixed of 10 bills and 20 bills. He wants to know how many of each kind of bills Andrew receives. So first, second is we apply the strategy. Let's start by making a table of the different ways Andrew can have 12 bills in tens and 20s. Andrew could have 12 10 bills and 0 20 bills, or 11 10 bills and 1 20 bills, and so on. We can calculate the total amount of money for each case. If we have 12 pieces of 10 bills and 0 20 bills, is equal to 120. And second is, if we have 11 pieces of 10 bills and 1 piece of 20 bills, the total amount is 130 bills. And the third is, if we have 10 pieces of 10 bills and 2 pieces of 20 bills, the total amount is 140. And fourth is, if we have 9 pieces of 10 bills and 3 pieces of 20 bills, we have 150 bills. And if we have 8 pieces of 10 bills and 4 pieces of 20 bills, we have 160 bills. And if we have 7 bills and 5 pieces 20 bills, we have 170 bills. And if we have 6 pieces of 10 bills and 6 pieces of 20 bills, we have 180 bills. And if we have 5 pieces of 10 bills and 7 pieces of 20 bills, we have 190 bills. And if we have 4 pieces of 10 bills and 8 pieces of 20 bills, the total amount is 200 bills. And if we have 3 pieces of 10 bills and 9 pieces of 20 bills, the total amount is 110. 210. And if we have 2 pieces of 10 bills and 10 pieces of 20 bills, the total amount is 220. And if we have 1 piece, 7 pieces of 20 bills, the total amount is 230 bills. And if we have 0 of 10 bills and 12 pieces of 20 bills, the total amount is 240 bills. In the table, we listed all the possible ways you can get 12, 10 bills and 20 bills and the total amount of the money of each possibility. And the correct amount is given when Andrew have 6 10 bills and 6 20 bills. Answer is Andrew gets 6 pieces 10 bills and 6 pieces 20 bills. To check if the answer is correct, 6 pieces times 10 bills and plus 6 pieces times 20 bills is equal to 60 bills plus 120 bills is equal to 180 bills. And the answers check out. Let's solve the same problem using the method look for a pattern. Method 2, looking for a pattern, is first is to understand. Andrew gives the bank teller a 180 check, and the bank teller gives Andrew 12 bills. These bills are mixed of 10 bills and 20 bills. He wants to know how many of each kind of bills Andrew receives. And let's start by making a table just we did above. However, this time, we will look for a pattern in a table that can be used to find the solution. Apply strategy. Let's fill in the rows of the table until we see a pattern. We see that every time we reduce the number of 10 bills by 1 and increase the number of 20 bills by 1, the total amount increases by 10 bills. The last entry in the table gives us a total amount of 140 bills. So we have 40 bills to go until we reach our goal. This means that we should reduce the number of 10 bills by 4 and increase the number. That could give us 6 10 bills and 6 20 bills. 6 10 bills times 6 pieces of 10 bills plus 6 pieces of 20 bills is equals to 180 bills. So Andrew gets 6 10 bills and 6 20 bills. To check, 6 10 bills and 6 20 bills, 6 times 10 bills plus 6 times 20 bills is equal to 60 bills plus 120 bills is equal to 180 bills. And the answers checkouts. You can see that the second method we used for solving the problem was less tedious. In the first method, we listed all the possible options and found the answer we were seeking. In the second method, we started by listing the option, but we found the pattern that helped us to find the solution faster. The method of making a table and looking for a pattern are both more powerful if used alongside other problem-solving methods. Difference of looking for a pattern in other problem-solving strategy. The difference of look for a pattern in other problem-solving strategy is a strategy in which students look for patterns in the data in order to solve the problem. Students look for items or numbers that are repeated or of event that repeated. Worded problems applying in looking for a pattern. Example 1. Sarah was trying to finish all her math homework on Friday. She did 3 problems at the first 30 minutes and 4 problems the next 30 minutes and 6 problems the next 30 minutes and 9 problems the next 30 minutes and so forth. If she continues to work at this rate, how many problems will she have done in 4 hours? First is to explore. Sarah worked 30 minutes per problem set. Time work, number of problems worked. First 30 minutes, Sarah done 3 problems. And second 30 minutes, Sarah done 4 problems, increased by 1. And third 30 minutes, Sarah done 6 problems and increased by 2. And fourth 30 minutes, Sarah done 9 problems, increased by 3. So, sunod is plan. Look for a pattern. The difference between the numbers increases by 1 each time. And answer is 30 minutes. Sarah done 39 problems, increased by 7. That's Sarah done in 4 hours. Example number 2. Write a rule to find the successive terms in the pattern. 63, 5, 24, and the number decreased by 15, then 13, then 11, so the next number should decrease by 9, and then by 7. The number subtracted decreases by 2 each time. And example number 3. 1, 2, 4, 8, and so forth and so on. And find the next 2 numbers. This example is little bit harder. The number are increasing but not by a constant. Maybe a factor. So, let's factor. 1 times 2 is equals 2. And 2 times 2 is equals 4. And 4 times 2 is equals to 8. So, each number is being multiplied by 2. So, the next 2 term is 8 times 2, 16 times 2 is equals to 32. So, the next 2 terms is 16 and 32. Example 4, 1, 4, 7, 10, 30, and so forth and so on. And find the next 2 numbers. And the pattern in each number is increasing by 3. The next 2 numbers should be 16 and 19. Example number 5. 1, 4, 9, 16. Find the next 2 numbers. It looks like each successive number in increase by the next odd numbers. So, parang 1 plus 3 is equal to 4. Tapos, 4 plus 5 is equal to 9. And 9 plus 7 is equal to 16. So, the next number should be 16 plus 9 is equals to 25. And 25 plus 11 is equal to 36. And so, the next 2 numbers is 25 and 36. Problem solving strategy number 7. Working backwards strategy. Learning objective. At the end of the lesson, students should be able to know the definition of working backward strategy, the relationship of Pauli's problem working backward solving strategy, and the difference of working backward strategy from other problem solving strategy, and worded problems applying in working backward strategy. Working backward strategy. The work backward method works well from the problem where a series of operations is done on a unknown numbers and you only give the result. To use this method, start with the result and apply the operation in reverse order until you find the starting number. Addition, subtraction, multiplication, division, and relationship of Pauli's method in working backward strategy. In this section, you will learn about the methods of guess and check and working backwards. These are very powerful strategies in problem solving and probably the most commonly used in everyday daily life. Let's review our problem solving plan. The strategy for the method guess and check is to guess the solution and then plug the guess back into the problem to see if they get the correct answer. If the answer is too big or too small, make another guess the goal and continue guessing until you achieve the correct solution. The process might sound long, but often you will find the patterns that you can use to make better guesses along the way. Example, Nadia's father is 36. He is 16 years old, done 4 times Nadia's age. How old is Nadia? Solution. This problem can be solved with either of the strategies that you learn in this section. Let's solve using both strategies. Guess and check method. We need to find Nadia's age. We know that her father is 16 years old, older than 4 times her age, or 4 times Nadia's age plus 16. We know her father is 36 years old. Step 2, strategy. We guess a random numbers for Nadia's age. We multiply the number by 4 and add 16 to check if the result is equal to 36. And if the answer is 2, we guess a larger number. And if the answer is too big, we guess the smaller number. And we keep guessing until we get the answer is to be 36. Step 3, apply strategy. Guess Nadia's age. Example 10. 4 times 10 plus 16 is equals to 56. Too big for her father's age. And so guess a smaller number. 9. 4 times 9 plus 16 is equals to 52. Still too big. Guessing 9 for Nadia's age give us a number that is 16 years too great to be her father's age. But notice that when we decrease Nadia's age by 1, her father's age decreased by 4. That suggests that we can decrease our final answer by 16, and if we decrease our guess by 4 years, 4 years less than 9 years is 5. So, 4 times 5 plus 16 equals to 36, which is the right age. The answer is Nadia is 5 years old. Step 4. Check. Nadia is 5 years old. Her father age is 4 times 5 plus 16. The answers check out. Work backward method. Step 1, understand. We need to find Nadia's age. We know her father is 16 years older than 4 times her age. Or 4 times Nadia's age plus 16. We know her father is 36 years old. Step 2, strategy. To get from Nadia's age to her father's age, we multiply Nadia's age by 4 and add 16. Working backward means start with the father's age, subtracted 16, and divided by 4. So step 3, apply strategy. Start with the father's age is equals to 36. And subtract 16. So 36 minus 16 is equals to 20. And divide by 4. 20 divided by 4 is equals to 5. So the answer is Nadia is 5 years old. Step 4, check. Nadia is 5 years old. Her father age is 4 times 5 plus 16 is equal to 36. This is correct. The answers check out. You see that in this problem, the work backward strategy is more straightforward than guess and check method. The work backward method always works best when we know the result of the series of operations, but not the starting number. Difference of working backward on other problem-solving strategy. The difference of working backward on other problem-solving strategy is a strategy in which students start into the last part of the given in order to solve the problem. Students use guess and check strategy in order to solve the problem. Worded problem. Applying in working backward strategy. Example 1. Karen is thinking of a number. If you double it and subtract by 7, you obtain 11. That is Karen's number. We started with 11 and work backwards. Opposite of subtraction is addition. We will add 7 to 11. We are now have 18. The opposite of doubling something is dividing. 18 divided by 2 is equals to 9. This should be our answer looking backward. 9 times 2 is equals to 18. Minus 7 is equals to 11. Then Karen's number is 9. Example number 2. Jack walked from Santa Clara to San Palto. It took 1 hour and 25 minutes to walk from Santa Clara to Los Altos. Then it took 25 minutes to walk from Los Altos to Palo Alto. He arrived in Palo Alto at 2:45 p.m. At what time did he leave Santa Clara? Strategy. Understand what you need to find. You need to find the time was when Jack left Santa Clara. So, plan. How can you solve the problem? You can work backward from the time Jack reached Palo Alto. Subtract the time it took to walk from Los Altos to Palo Alto. Then subtract the time it took from walk from Santa Clara to Los Altos. Solve. Start at 2:45. This is the time Jack reached Palo Alto. Subtract 25 minutes. This is the time it took to get from Los to Palo Alto. Time is 2:20 p.m. Subtract 1 hour and 25 minutes. This is the time it took to get to Santa Clara to Los Altos. And Jack left Santa Clara at 12:55 p.m. Example number 3. It takes Lydia 30 minutes to walk to school, 30 minutes to get ready, and 15 minutes to eat. School starts at 8:15. What time should she get up? So first is 8:15 a.m. minus 15 minutes is equals to 8 a.m. So 8 a.m. minus 30 minutes is equals to 7:30 a.m. And 7:30 minus 30 minutes is equals to 7 a.m. The answer is 7 a.m. that Lydia should get up. Example number 4. I think of a number and add 3 to it. Multiply the result by 2, subtract 4, and divide by 7. The number I end up with is 2. What is the number I first thought of? So, going to strategy of backward. 2 times 7 is equals to 14. So, 14 plus 4 is equals to 18. 18 divided by 2 is equals to 9. So, 9. The answer is 6. That's the number first thought. So, let's going back. So, 6 plus 3 is equals to 9. 9 times 2 is equals to 18. 18 minus 4 is equals to 14. 14 divided by 7 is equals to 2. Example number 5. Anne has a certain amount of money in her bank account on Friday morning. During the day, she writes a check for $24.50, makes an ATM withdrawal of $80, and deposit a check for $235. At the end of the day, she sees that her balance is $451.25. How much money did she have in the bank at the beginning of the day? So, $451.25 minus $235 is equals to 216.25. So, 216.25 plus $80 is equals to 296.25. So, 296.25 plus $24.50 is equals to $320.75. So, $320.75 and have money in the bank at the beginning of the day. Summary. The look for a pattern. The goal is to look for a repeated or series of events that repeat. And second is the method make a table is useful when solving problem involving numerical relationship. When data is organized in the table, it's easier to recognize patterns and relationship between numbers. Third is the difference of look for a pattern in other problem solving strategy is the strategy in which students look for a pattern in the table data in order to solve the problem. 4. The work backward method works well from problems where a series of operations is done on a unknown numbers and you're only give the result. 5. The method guess and check. If the answer is too big or too small, make another guess that will get closer to the goal and continue guessing until you arrive to the correct solution. Lastly is the difference of working backward in other problem-solving strategy is strategy in which students start into the last part of the given in order to solve the problem. Thank you.